I know I've been gone for a while, but I'm back with KNN video. And for the KNN series, or in general, let me know what's working and what's not working. That's me trying to draw a heartbreak, but I'm not very good at it. So that I can focus on the not working part and we make sure that we're emphasizing the working part. Anyway, the goal is to maximize our learning, so please do let me know in the comments and feel free to like the video if it's helpful and dislike the video if it's not helpful. Okay, so let's get started. So in this video, it's going to be sort of a recap of things we looked at in the last video, but now we're trying to bring everything together and have pseudocode. So this one is going to be intuition, math, and pseudocode. So step one, representing data point. Representing data point. Okay. So imagine that you have a basket of fruits, and then in that basket of the fruits, there are two important features, and let's say those are size and then weight of the fruit. Okay, so you can think of each fruit as a point on a 2D grid where one axis is size and then the other one is weight. Okay, so each fruit is represented as a point with coordinates, size, and weight. And you also know its type, for example, whether it's an apple or orange, etc. Or a numerical value if we're doing a regression. So when we think about the pseudocode for it, it could be something just like this, right? Fruit and then features and then label or value, right? And when you're creating your data set of fruit, it could look something like this. Training set then would just be fruit 1, fruit 2, and so on, right? Now, since we're doing KNN, our step 2 is measuring similarity. Measuring similarity. And I know we looked at two different distances last time, Euclidean and Manhattan. For now, let's stick to Euclidean, okay? So to decide how similar two fruits are, you measure the distance between them on the size weight grid, okay? So imagine stretching a measuring tape from one fruit's position to another's in the grid. That's basically what we're trying to do here while we figure out the distance in step 2. So the Euclidean distance between two fruits, say fruit A and fruit B, oh, I really cannot spell today. What is going on? Maybe I'm out of practice. Okay, so Euclidean distance for fruit A and fruit B such that fruit A has x1, y1, its features, and then fruit B has x2, y2. Could be, and we're saying this is weight, this is, what did we say? This is size, this is weight, sorry. This is size, this is weight, size, and weight for respective fruits, right? So the Euclidean distance is simply x2 minus x1 whole square plus y2 minus y1 whole square, and then everything is on square root, okay? So if we look at the pseudocode for this, what might it look like? Let me use a different color for pseudocode. Yellow is too yellowy. Okay, this, okay. So maybe it could, we're gonna stick to something really simple. So maybe it could be like function, say compute Euclidean distance, and then fruit 1, fruit 2, then we'll say set sum squared difference. We initialize it as 0, and then what we're going to do is for each fruit index I from 1 to number of features, the difference is going to be fruit, and it's pseudocode, right? I try to write pseudocode because not everyone's trying to learn Python. So if I go and code on Python directly, it's going to be confusing for everyone. And also because I want you to try it yourself. Now that you have pseudocode, go on Python, play around and give it a try yourself. Okay? And of course, we'll do it together too, but it's a good practice. So that's going to be your difference. And then some squared differences then could be some squared differences plus difference times difference, right? For this one, we're squaring it. And then at the end, distance is just your square root of the whole thing. Some squared differences, and then what do? We just return distance. Okay, that's it. Okay, very, very simple. And step 3 now is choosing the number of neighbors. Choosing number of neighbors. Okay, I am so sorry. I do not know why I can't spell today. I feel like my brain has been very foggy lately. I used to be good at spelling things, but these days I don't know. Maybe it's my ADHD getting worse, but no clue why. Anyways, so choosing number of neighbors, basically you decide how many nearby fruits you will compare to the new fruit. For example, if you choose your K to be 3, then you're saying you will look at 3 fruits. You look at 3 fruits that are most similar or closest to this new one, okay? That's all you are saying when you're choosing your K. So K mathematically is simply a positive integer that determines how many neighbors contribute to the decision. It's not computed by a formula, but it's chosen based on the problem requirement. So your pseudocode could be something as simple as really just this: K equals to 3, right? You're just choosing your K. Now step 4 would be finding the K nearest fruits. Find K nearest fruits. So for the new fruit, measure the distance to every fruit in your training set and then pick the K fruits with the smallest distances. So these are the nearest neighbors, okay? So again, you measure the distance to every fruit in your training set and then you pick the K fruits with the smallest distance. That's it. So we do have to sort all the distances in ascending order for us to be able to select the first K entries, okay? So let's work on the pseudocode. Let me choose this color. No idea what I choose. Oh, I think I chose that. Okay. Function get K nearest neighbors new fruit. And do let me know in the comments if I am not explaining certain thing enough, if I need to make a separate video to drill down on a certain concept. I would like to know, okay? I want to know what's working and what's not. So say distance list equals to empty, and this will store pairs of fruit in distance for us, okay? So for each fruit in training set, distance will be compute Euclidean distance here, this one, compute Euclidean distance, and then you're giving it the new fruit and that fruit. And what we're doing here is adding fruit, comma, distance to the distance list. Okay, makes sense? Now, next we want a short distance list based on the distance value with smallest appearing first. Okay, so we are going to sort distance list by distance in ascending order. And then what we'll do now is pick the first k fruits that come from the sorted list. It's pretty easy, right? When you break it down, it's not that difficult at all. K nearest neighbors equals to first k elements from distance list. And then you simply return k nearest neighbors. Okay, pretty easy, right? Now let's look at the next step. Next step is making prediction. We're already there. Make prediction. Okay, so let the k nearest fruits vote on what the new fruits type should be. The type that appears most often among the neighbors is then chosen as the new fruits predicted type. So mathematically, all we're doing is counting frequencies of each type among the k neighbors and then selecting the most frequent one. I can't spell, I can't pronounce, not sure what's going on. Okay, so very, very easy. All we're doing is counting the frequencies of each type among the k neighbors, and then we're sort of taking it as a vote to decide what the new fruit should be. Okay, so function predict label for new fruit training set and your k. So k neighbors equals to get k nearest neighbors new fruit training set k, then set vote counter equals to, I'm just gonna have a empty dictionary here. Now for each, sorry, that's my phone, don't worry, it's not yours. Distance, sorry, k neighbors label equals to neighbor fruit dot label. So if label exists in vote counter label equals to vote counter label plus 1, else vote counter. We're just recording votes, right? Nothing too fancy going on here. So yeah, we're just looking at how many votes we have for a label, and then now we are finding the label with the highest vote count. So predicted label equals to label with maximum count in vote counter, and then we just return the predicted label. That's it. And just a note for regression, when you're predicting a numerical value, maybe things like say a sweetness label. So say you're predicting a numerical value instead of fruit type, you average the value. We said sweetness. So maybe, yeah, we average the value such as sweetness to the k nearest fruits, and then this gives you a smooth prediction based on nearby fruits. So here your predicted value, here you were doing regression, would be predicted value equals to sum of values of neighbors by k. So instead of voting, you're sort of just computing the average. That's it. Other than that, everything is pretty similar. So yeah, recapping what we did, we represented each fruit as a point with its size and weight plus either a label or a value if it's a regression. Label, yeah, we said label here. And then for distance, all we did was Euclidean distance, and then we chose a k value for a new fruit. We chose a k value, that's it. And then step 4, what we did was just find k nearest fruits, and the k here was determined from here. Why am I rumbling? Okay. And then at the end, we just made predictions.